welcome, everybody. Thank you for coming to join our session about distributing best practices for distributing IP. I'm Niki Budgell. I am the product manager for NI Package Manager, and well as the licensing technology. And then I have presenting with me Scott Richardson and Jim Kring from JKI, and then Scott is a product owner for NI Package Manager. And so today we're going to talk about historically what has been some of the best practices for distributing IP and packages, and then talk about how NI is using technologies to distribute that distributed packages. And then we'll go into a little bit at the end of future technology for NIPM and trying to get some more feedback from all of you guys. All right, then I'm going to pass it off to Scott to start us off.
All right, cool. So hopefully you can hear me. Is that the right level of, can you guys hear me? Good, great. All right, so she outlined a little bit of the agenda. I'm going to stay here so I can see slides instead of staring at that one. So historical goals for distributing IP. We're going to go back in time just a little bit to understand where we came from and where we're going. And part of that also is we're going to look at sort of our NI solutions that we have in our platform to help you distribute your IP. And lastly, as Niki mentioned, we'll discuss roadmap and discuss your needs. So what are the goals of distributing IP? I bet everyone here, it's all different for everyone, but let's talk about that a little bit. So one step back from that, what is software IP? Well, in general, it's the work that you create so that you can share that with others, right? So it could be manuscript paper in the old form, but it's really the design from a software perspective. So for us, that really is, what is our source code and how we distribute that source code in what form? It could be the actual code itself that we're distributing. We have code, algorithms, model, data, whatever it might be. In addition, what is the form? Is it source code, or is it going to be some sort of library or application? You have to sort of ask that for yourself. What level of protection am I trying? What's my goal of my IP? Do I want to just share it and then offer service? Or is it really, no, what I'm handing out is really critical to me, and I want to continue owning it and handling it. You could give it up and say, here's the source code, open source, go have fun, but you still might own it. Or you might try to compile it, hide the details from it, and from there, could someone still get access to that? Maybe. Another aspect is you might hide it behind a web service. So all they see is the UI experience. They don't know anything about how it's implemented and everything else. So these are all questions you have to ask about. What is your IP? How you want to distribute it? What is important to you? So early needs for distributing IP are fairly straightforward and simplistic. Most developers and their end users weren't connected. Part of the reason is because most of our systems weren't connected via the internet. So the basic needs were fairly straightforward. We wanted to make sure that developers and their end users, that's both us to you and you to your end users, have the ability to do something very simple. One is to have an installer to install the software that you're interested in. Interactive, silent is important. But back in the olden days, it was what's the media you're going to use? Floppy. Anyone use floppies? You have CDs, DVDs, USBs. Obviously, we're graduating as time goes by. Licensing and activation is important. We want to make sure that our end users are licensed to use it, but we also want to make sure that it's fairly easy to activate. It was an important piece. How you build your projects for your end user, for you to deploy. How are you building your installers, which is really the main first technology we're going to talk about. And then automation. How do I automate some of those processes so I'm not doing everything manually by hand? So I created a solution in 2003, which was based off of Microsoft's MSI technology. That was our initial focus. We wanted to present a consistent UI. Prior to this technology, we heard complaints saying, hey, installing works great sometimes, uninstalling causes more problems. I install one software, another software, they don't work very well together. So we heard that, we ended up creating this installer framework, and that allowed for a couple things. Consistent UI, reliability on install operations, install, repair, uninstall. And we use this for all of our NI software. Internal needs that we had was we wanted to be able to componentize our software in some form. Instead of installing every component in multiple places on the hard drive, it might be nice if we could share that, right? So that's an important thing as you design your software. And also there might be things that are optional. I don't want to install everything onto your machine. You might want to be able to pick and choose as an end user what you might want to do. Other things were important is defining those dependencies primarily in this time frame. Is it a requirement to have this other thing installed in order for my thing to work? How do we display EULAs, which talks about licensing and also activation? All these things were important. And then in 2005, we realized there's another piece of this that we have to address. And of course, this was sort of designed from the beginning, which was that you as customers and your end users who want to use and deploy your products need to be able to create their own custom components. In addition, add in what other NI components are required along with that. So we added support for building custom installers, both initially to LabVIEW 8.0, and then we also added eventually to LabWindows CVI, Test-In, Measurement Studio. And by using the same technology, both for NI as well as for your custom components you're creating, it was all the same framework, had a level of commonality that allowed us to introduce new features. Simply, I mean, there's multiple ones, but a common one was 64-bit support. Different OSs that we go forward, making sure those are supported. So best practices in that time frame was, how do we install software? Fine, use our installer technology, our suites to get our software onto your system so you can develop successfully. There are CLI and specification files that went on with the installer that currently allow you to automate some and customize some of those installations. We also created a while ago something called a Bash Installer Builder. Really, what was it? The ability to combine multiple installers into one so that you can customize it and make that go out. Okay, and that was all part of this whole installer technology. You've probably heard of Volume License Manager, which allows you to manage your licenses internally to your intranet. And we have a feature of that, which is Volume License Installer, which is similar to Batch Installer Builder, which allows you to customize the installer that you want at a high level, and then add the proper logic in to call home to that VLM server to say, hey, when you want a license, go here. Licensing activation was another need, as I mentioned. So we have inline activation. We have activation through our license management GUI, as well as through the CLI. So this was something early on we wanted to try to help with. I mentioned Volume License Manager to manage your software internally. And then there's also third-party license activation toolkit for LabVIEW to license your software. The third need was, as I mentioned, was sort of building your project installers. That's where the ADEs come in, LabVIEW, CVI, Test-In, Measurement Studio to build your own installers and to customize them through the APIs and do automated builds. And that met some of the dependency model needs. So fast forward today. What's more important today? Some of this might be important to some of you. Some of you might have been hitting some of these roadblocks for a while. Systems are much more connected. The end users have higher you as well as your end users have higher expectations on the efficiency of your development, how you deploy updates, how you can, in general, people are more savvy technically. So some of the needs that we believe that are there that you can identify with installers aren't good enough. You now need to be able to pull software off the network in an easier fashion. More components need to be reused. How do you manage those? Your dependencies as well go into that. You want to automate and your test process even more, continuous integration. You build a new version of the binaries. How do you get that into an installer automatically? You don't want to have to do it all manually. Now that we're interconnected, I now have distributed systems. Wouldn't it be nice if in some way I could actually push my installers and products to those clients in some way? Maybe. And lastly, the notion of continuous delivery. The notion of, as I mentioned, continuous integration. I build it, then I want to make sure I deliver it in some automated fashion. How do I go about doing that? So we're going to talk about some NI platform solutions that we have today to help you distribute your IP. And on the left really is sort of the high-level things we might want to do. It's building installers and for targeting systems, automating the build processes. Both of those are addressed by what we call NI package management, that suite of things. You as developers using LabVIEW want to be able to reuse libraries, share those internally, share those with your clients and your end users. We're going to talk about how JKI VIPM helps facilitate that. And for updating remote systems, NI has a product called SystemLink, and we'll touch upon that briefly. And we talked about licensing activation. We're not going to be talking about that in much detail at all, But I want to mention NI License Manager really is the thing you should be looking at to understand that better. And as we go forward, we'll be making more improvements on that for you all. All right, NI Package Management, what is it? It's the ability really to use building packages. We'll talk about what that is. And I want to focus, it's really on the system level. NI Package Management is targeting packages or installing software at the system level, meaning I'm installing a component in one place on the system. I'm not necessarily taking that component and putting it in multiple locations on the system. That's more for JKI and LabVIEW to look at. So we talked about what I'm going to call the legacy framework. That's the old framework, which all of you are likely mostly still using in some form. But by 2018, we realized there were some missing needs. So I'm going to go through these really quickly. You really didn't have access to really control the packages or understand what packages and components were actually installed on your system. Package Management was going to try to address that. The framework did not support web-based distribution, only installers. Everything was sneakernet. Installation didn't have the ability to download only what you need. You pretty much got the whole offline installer from the legacy framework. You didn't have the ability really to do more complex upgrades and patches. Everything was on a very high level. If I want to patch it, I patched almost the whole thing. Dependency model capability. Yes, I could depend on something, but what if I recommend something? What if I have a conflict with something? What if I replace something? These are the constructs for the relationship management that you might want to be able to do that's not supported by the old framework. Also, as I mentioned, to control remote systems, this is SneakerNet timeframe using the legacy. There is really no notion of controlling remote systems. And lastly, as end users, you might have custom workflows you might want to do. Our legacy framework really doesn't support those custom workflows very well. However, package management does. So let's first talk about just real quick, what is a package? Package really is an installable component that represents any one of the following. The high-level product itself, maybe a tool within a product, a driver, a library, or maybe just a bunch of files, documentation. That's what a package can represent. In the end, it's a bunch of files with the directories of where that content should go. In addition, there's other stuff, of course, like what is the name of the package, what is the description, who is the company, what is the email address to contact, website, and of course, version, which is very important. There's also other capabilities like you can run things after the package is installed, before the package is installed. So these are custom execute actions that you can take. And of course, dependency information, which I said is something that's very important to work on. In general, you deploy packages using two concepts. One is a feed. One says, here's a bunch of packages that are related. The topmost might be a product, and there's a bunch of packages. It's just a list of those packages. Where those packages are may reside in disparate places depending on the URL that is inside that feed. So in the end, there's a repository, one or more repositories or pools that have all the actual packages in them. All right, Package Manager GUI, I'm sure you've seen that when we introduce this, when you now uninstall your software, even your legacy software, it goes to Package Manager to uninstall that software. So we're sort of merging these two technologies, and that's important. You can browse for NI products from NI.com through this application. You can understand what packages are installed or available at a lower level, both at what we call products, so there's a filter on that, so you can look at products or just all the low-level packages that might be installed or available. There's the facility to do upgrades and patches. Of course, you can repair and remove packages, and the configurations for filtering what you see, understanding what repositories or feeds, what feeds you're connecting to that you can actually pull your packages from, and then some low-level options for seeing a little bit more detail of the packages that are installed or available. GUI is nice. Automation is also very important. So there's a low-level application called NIPKG-EXE, which allows you to do everything that you can do in the GUI and more, but at a low level, and it's automated. So all these little capabilities here: install, update, repair, remove, registering the feeds, getting listings of what's installed or what's available. You can download packages from registered feeds to an arbitrary location on your hard drive. You can pack, which really means create a package. You can unpack them. So a common thing might be to do is I created a package, I can unpack it, make some changes, repack it. So this is the low-level capability of just creating a single package. You have the ability to create the feeds that I mentioned, which are the list of packages and where those URLs are to. And all the command line help has all the help available for these type of commands that are available. So packages might be kind of cool, but then the question is, are installers still supported? The answer is yes. Let me talk a little about just so you understand that. So Package Manager includes the ability to create what we call a package installer. In the end, what it is, to the user is a wizard that you normally see, prompts you, says, hey, I'm about to install these items. Which ones do you install? These are required, these are optional. Do I continue? Yes, install, confirmation it was done. So we offer sort of two installers. One you've seen when you download what we call an online installer from ni.com. That's the default download, which really is a small little payload, very small, has the feed information in it, but it connects to ni.com to actually download all the packages and do the installation. So a very small payload, but it requires network connectivity. The offline is what you're more familiar with, which is sort of the legacy approach, which is you have an installer executable. The feeds and the packages are all next to it on the disk. And from that is a single package that will install all the software that you need for an offline system. Of course, we support interactive and silent modes. And I want to mention, the notion of a suite, because they'll come and play a little bit later, is that as you see on the right-hand side, that is a suite for LabVIEW. It installs both LabVIEW and drivers and everything else in toolkits. It's the notion of having multiple top-level packages, products, if you will, for installation. So how do you build packages and installers? There's a tool chain, both and various ADEs to do that. So in LabVIEW, you might be familiar that there's a build specification called installer. Don't use that one. That's the old technology. There's a new build specification called package. And that allows you to build a package, a feed, and/or an installer. And of course, like any build specification, it understands all the specific needs for LabVIEW to build that package properly, so you have the proper dependencies and everything else. Another feature is that you can actually upload some of those packages or into a feed inside of SystemLink, and I'll touch upon that a little later. Also important is automation, so they have the ability through CLI and API to be able to automate some of these build processes like you can do with the installer build specification. Testing has something called a deployment utility. In a similar fashion, it understands how to build components in order to be deployed for test stand. Package, feeds, and installers are all supported, but it really knows how to handle test stand sequence files as well as dependencies necessary for test stand. Of course, CLI is also available to build that solution. Also want to point out that there's a newer, more recently released solution for building packages called NIPM Builder. The purpose of it is really focused on a solution for package management, such that you can build multiple packages, multiple feeds, and multiple installers. It does have support for test and deployment workflows. It does build a suite installer. So before I mentioned this notion of both batch installer builder as well as a volume license installer, has the capability. You can feed into it multiple installers that we might have released or you've created on disk and create the union or some version of that you can add to your own separate installer. Of course, there's a CLI for building the solutions there as well. So best practices in general in a package management, we're trying to solve two problems. One, how can the needs for installing software delivery on connected networks, so you have package manager GUI and the CLI to facilitate doing that installation. And from an automation perspective, all the solutions I mentioned, NIPKG and all the installer builders have the ability to automate. And that'll help them meet your needs for continuous integration. Now on to JKI.
Hi, everybody. Good to see you. So I was invited by NI to speak a little bit about VI Package Manager as a tool for building packages of LabVIEW reusable code for your projects. I I guess in some ways, we were fortunate. We put in about 20 years working on VI Package Manager. And now that the current gen LabVIEW is the path forward, VI Package Manager continues to stay relevant. And we're putting in a lot of work into making it even better. So how many people here have used VI Package Manager in some way, shape, or form? And how about for building packages of your own stuff? Have you guys created like a repository to share packages? How many people have used the package configuration files? So that's actually something that's pretty interesting that a lot of people in the room will probably maybe take away today, is that package configuration files are really helpful for organizing your LabVIEW projects. How many people knew that there was a free community edition of VIPM that does pretty much all the stuff that Pro does? Mostly? Okay, great. So you guys already know this, but VIPM aims initially, first and foremost, to make it easy for you to find code and get it into your LabVIEW palettes fast. That was essentially the first thing we wanted to address 20-some years ago as we were sharing OpenG code. We decided to make lots of zips instead of one big zip. And then once we had lots of little zips, make it easier to put it into VI lib. And that was kind of the evolution of VI Package Manager. It ships with LabVIEW, allows you to search for LabVIEW tools. You can find everything that's on the NI LabVIEW Tools Network, and then also everything that's on VIPM.io shows up there. I'll talk a little bit about that later. Has anybody been to the VIPM.io website? You can find lots of good stuff there. And also, VIPM allows you to build packages of your reusable code. And I'll talk about these other things here in a second. In terms of best practices for distributing reusable code, there are a lot of kind of cool options down in the install requirements that allow you to specify dependencies. The package builder will find dependencies automatically. You can even declare whether you want them to be external dependencies that your end users will have, or you can delete them from the list of external dependencies, and VIPM will internalize them. It'll add some namespacing and include them in your package so that your end users don't depend on them explicitly. It's kind of like building it in. It also supports licensing and activation with NI's third-party license activation toolkit. Is anybody using that still? Okay. So this feature that I'm going to talk about, package configurations, there's a file that you can create with VIPM called a VIPC, VI Package Configuration File. It's a zip file, so it is itself sort of a package. And what it contains is a list of packages, plus optionally and by default, it has copies of the actual package files that it saves inside the VIPC. And so the packages that you're using in your LabVIEW project go along for the ride. And so if you have this VIPC file in your source code control system, you can check that in, push it, and any developer who pulls the code, if they have LabVIEW installed and VIPM installed with LabVIEW, they can just double click that file and it'll say, do you want to install these in LabVIEW? You can say yes, and it'll install them. The VIPC also contains information about what version of LabVIEW the project is in. And let's see here. In terms of kind of best practices, VIPCs kind of fall into the category of project configuration management and making it easy to have like reproducible deployments, reproducible builds, reproducible development systems. And an area that we're working on right now is improving the APIs that we have. So we have a VI-based API. We're working to make improvements to the command line API for continuous integration. Is anybody doing some kind of automated builds right now of their code? Okay. And I'm kind of curious from the audience, you can just kind of throw out some names of like tools or ways you do continuous integration. How do you run your builds? Jenkins? GitLab CI? Bob's computer in the corner? Okay. Who here knows what Docker is or has heard the word Docker? Okay. Who actually knows kind of what the technology is? And who's using Docker on a semi-regular basis? Okay. Good. And we'll talk a little bit about that. Who's doing some form of like GitHub or GitLab actions? Cool. So starting with the actions, basically GitLab and GitHub have some servers running Windows or Linux, and you can create a configuration file in your project, which is an action or a workflow. And essentially this is like in an installer build. You know how you can have like a pre-install, post-install? Well, these are actions that run on a build server when you push code. And you can specify when they run, like if it's tagged, et cetera. And with these, you can actually then invoke lab views build. You can invoke package builds. You can invoke package installation, all kinds of stuff. So it's essentially a way to programmatically get your build system into the right shape and do all the steps, running unit tests, et cetera. Docker is a technology kind of for virtualization. And it allows you to essentially create your own images of these kind of runners that you want your stuff to run on. So I was just kind of curious who's using that. But this plays nice in that ecosystem. So does the NI package manager. I think this is my last slide here. So in terms of sharing packages, VIPM.io has a page you can go to for publishing a package to the community. And as long as it's open source through one of the officially, sanctioned, blessed open source licenses, there's a list of them. The popular ones being like BSD, MIT, Apache, et cetera. You can post your stuff there for free to make it available to the community. How many people have done something on GitHub where you've either contributed or posted a project of open source? Okay, how many people have downloaded something from GitHub? Okay, and I'm sure those of you who didn't raise your hand probably have used or downloaded something that the development has happened there. It seems like it's the way a lot of things are going. VIPM.io, we actually have our issue tracker, public issue tracker hosted on GitHub at github.com/VIPM-io. You can probably find the link at the bottom where I've cropped off. But yeah, check that out. Also, for sharing packages privately, we have a pro and enterprise version. And then, we're also talking with NI about ways that we can better interoperate with NI Package Manager and the LabVIEW project environment. We've been working really hard on Dragon. You guys have probably seen presentations. It's been sort of a long couple of years, to say the least. A lot of things going on with LabVIEW, JKI, and how everything integrates. So that is not yet publicly released, but has anybody seen or downloaded the LabVIEW 2022 beta? Public beta is officially out. Yeah, you can use it. We're going to be posting the VIPM 2022 beta shortly too. So stay tuned.
Okay, it's on. We'll talk just briefly about SystemLink. SystemLink is a network solution for allowing you to manage a distributed system and much more. I'm just going to talk briefly on it. I want to focus really on the first item, which is the route system management. But let's talk about it in general. SystemLink allows you to manage your software and your data for your test and measurement systems on the network. Some of the capabilities include this remote systems management, which we're talking about shortly. Its focus really is on the clients that it connects to, meaning the system is going to connect to, the assets that are on there, what software is on there and everything else. From a test asset management perspective, it's looking really at your hardware, your configuration of that hardware and everything else. Test monitoring results, if those test systems are generating test results, like test data and everything else, you can push those results back into SystemLink. You can run reports, you can monitor that, do alarming and notifications, everything else with that. And the fourth module that's on there is the measurement data management, which allows you to analyze, to gather data, analyze the data, and it could be in disparate locations, doesn't necessarily have to be all pushed to SystemLink. The main thing I want to talk about is just remote system management, to touch upon what its capabilities are. Its main purpose is really to discover and manage the client systems that actually connect to SystemLink through your network. And the following capabilities. One is any client can request to connect to it, but SystemLink itself will manage whether or not it will acknowledge that connection. So at the server level, you can control who's actually connecting to the services. You have the ability to upload packages to SystemLink, so they will actually manage those pools of packages, as well as what feeds can be published from SystemLink itself. And so then it's up to whether for those clients to then access those feeds in a sort of in a manual way. However, because SystemLink has control or access to these clients as sort of like a service, they have the ability to install software, push the software down there, control what fees that client system has access to. And all this is being done is using NI-Package Manager as a service, if you will, on all those clients. More importantly, though, when you're really trying to push software out, you want to be able to capture what we call states. States is sort of a collection of components that has been defined by a client. You can capture what that state is of all the software that's installed on that client. You could potentially compare that to some other clients that are underneath the system, and you could then say, well, install the Delta, or change this system to look more like this system, where you can push an entire state of software onto a client. Very powerful feature. Want to point out that because this is on a server, you have the ability to queue up these jobs, push these things out simultaneously, and update multiple systems at once. So you initiate a set of multiple jobs. From there, you can monitor the status of those jobs, and you get the visual notification within the system when it's complete. The last thing I'll mention is, not all clients at some point clients can say, hey, I'm not ready to be updated, or there might be certain cases. So there's a lock-on-lock capability, both directed from the client itself as well as from the server to say, I'm offline. It can't be updated for a period of time. So just high-level best practices for SystemLink really touches two things. One was the remote control of these systems and deployments. We can control the software that's being installed there and force certain systems into certain states that we want to do. The other key thing is automation. SystemLink has some very powerful APIs that allow you to automate pretty much anything that the UI can do. So in this context, the important things are I can upload packages to the server. Example, as I told you can do that actually from LabVIEW, so it's using similar APIs. You can control and update the feeds that are defined and exposed or exported from that server. You can access client system information to understand their states, and also you can push the jobs to force installation on these client systems. So very powerful. All right, we're going to go on to sort of what's next.
All right, so we're going to talk a little bit about what's next, what's coming with package management, what is the team actually working on right now. So as Scott had previously mentioned, we have this legacy package management technology, and we're actually moving more towards packages. In 2019, all of NI software moved over to supporting just the packages and kind of moving away, taking that first step away from our legacy technology, the MSI framework. As of right now, our ADEs still support both the legacy installer, which you can kind of see here in like the LabVIEW application builder, as well as the newer package builder or package installer. And so we are in the midst of trying to move over solely to the package-based technology and move away from the legacy installer. This is not something that's happening LabVIEW 2022. Do not worry, your projects are still working through this year. We don't have a set time frame for when this is going to happen yet. We are trying to figure out and work with customers like you to understand what are your essential workflows to make sure you have all of the necessary capabilities in the new technology to make this work, because we know that there are existing gaps in the new technology. And so this is more of a warning, heads up for new projects. If you can, start using the new package-based technology, because we are going to be pushing more and more towards that. But if you have specific needs, we'd love to hear what your workflows are like. This goes to a survey that's around the LabVIEW, kind of 80 specifically, and the LabVIEW application builder, and what are your capabilities there that what is essential to your workflow when you're trying to build your installers to provide to customers. We are working on a similar survey for test stand. If you're a test stand user and you're using either the test stand deployment utility or NI package builder, and when you're building your packages, I'm going to put my computer, I know this is kind of old school, but we're going to put my computer up here, and please come and enter your name and your email, because we'd love to send you that survey once we have it all finalized and get your feedback for those workflows as well. So this is one of the big things that we're currently working on right now, is moving and trying to make sure that we have the new package installer framework ready and ready for you all and your end users. The other area that we're exploring is Linux. NI software, we currently do support installation on certain Linux desktop offerings. We have a lot of drivers predominantly, as well as LabVIEW is offered on multiple Linux distros. But the installation experience isn't necessarily intuitive, specifically in the offline use case. And so we're currently exploring ways to how do we improve that installation process. We've currently published this offline installation KB that provides some scripts that can help ease the installation process. And so we are continuing to iterate and improve amongst these, as well as looking as NI works to identify the Linux roadmap as well to improve the installation experience overall. I will say from a strategy perspective, at this point, this is not about porting over NI Package Manager, the full GUI, over to Linux. We want to make sure our solution is within the Linux ecosystem. And so that is the strategy we are going at approaching this problem. And with that, that is the end of our presentation-wise. I did want to leave room for questions, comments, concerns. If you are interested in the test stand survey, I will move my laptop up front, and please come enter your name and email if you would be interested in filling out that survey as well. And thank you all for coming to our presentation today.